Okay, hi everybody. Today what I thought we'll do is we'll go through differentiation and basically why differentiation is important and why we actually even bother with it. Okay, so I hope you remember from year 8 maths that your teacher might have defined that, you know, on your straight line, as you continue on that straight line, your gradient is exactly the same. Now, the way I picture this is I imagine myself walking on this line. Okay, so say you have a line there and I'm going up the line. So at each given point, the gradient is exactly the same. I mean, I'm going to expect the same slope, right? I'm going to expect the same rise over run. So because the gradient doesn't change, if you look at your straight line formula, the gradient can just be a number. It doesn't have to be an equation or anything like that. It's a number because it doesn't change. So it's just one value. Okay, now let us consider more complex graphs, okay? Graphs that aren't like this, nice and curvy. Okay, so imagine me walking along this graph. Here I am. And as I move up this graph, up this function, every single point along, my gradient is going to be slightly different. Basically, eventually I'll get up to here and I'll like it because I won't have to go up here all the time. So my gradient there is going to be different. Then when I start walking down here, my gradient is going to be different. So at every given moment, at every given x interval, you see at every given x value, my gradient is slightly different. So now it would be wrong to use one particular value for your gradient. Instead of that, you use an equation for a gradient, okay? Something that, you know, because the gradient is always changing, then you define it using an equation. Okay, because at every given x value, you have a slightly different gradient. Okay, so how do we find this particular equation? Well, the way you find it is you first have to understand how to do something called differentiation. Okay, so this is second law of differentiation. Basically, to differentiate anything, you have to drop the power. And the second thing that you have to do is you have to decrease power, remaining power. Okay, so remaining power by 1. Power by 1. Okay, so the way to differentiate this particular example is to actually figure out the equation. So what the equation is telling you is how y and x change together. So if you're like somewhere here, the equation will tell you what your y value is. If you're somewhere here, the equation will tell you where that y value is. So let's work out the equation for this. Now I'm just going to assume that this is x. The factor here is just x on its own. The factor here, well, the solution at that given moment is x equals to 4. So when you convert it into a factor, you have x minus 4. Okay? And the solution for this given point here is x equals to 6. When you rearrange it, you get x minus 6. Okay? So that is our equation that relates y to x. Because I don't have any other coordinate up here or anything like that, I'm just going to assume that this is the equation for now. Okay, so let us see how we differentiate this. So you have to remember that you need to expand this. Okay, so we're just going to use the FOIL method here. So we're going to get x squared minus 10 plus 24. Okay, and then you're going to expand it one more time. So x cubed minus 10x squared plus 24x. Okay, so now that you have your nice equation that relates your y values to your x values, what you can now do is you can differentiate it. So remember that to differentiate it, you're getting the gradient, right? So what you're expecting to have, the actual y is not y anymore. It's basically the rise over run. So this becomes, when you differentiate, when you diff it, it becomes rise divided by run. Okay, and rise divided by run. Rise can be seen as the change in y values because it's going up. The run can be seen as the change of x values. So this is basically what you build, dy over dx. This is where it comes from. The d stands for the change. Okay, so let us differentiate this. So we'll have dy over dx equals to, now to differentiate this one, you just bring the 3 in front and you decrease the power by 1, so it becomes 2. To differentiate this, you go minus 20 and you decrease the power by 1, so it's just x. And to differentiate that last one, it's just going to be 24 because the power on this is 1. When you bring it in front, it's 24. And then you reduce the power by 1, so it becomes 0. And x to the power of 0 is just 1, so you get a constant. Okay, so let us analyze what we have found here. Here we have found the equation of your gradient for this particular line. So now that you have the equation to your gradient, now that you have that equation, if you're interested, if I tell you that, okay, I'm standing right here, well, maybe not there, okay, get rid of some of this stuff. Let's just say I was doing a lot of exercise and I got up to around about here. There. Okay, so that point may be 9, okay, and I might want to figure out what my gradient is, because I want to know how much work I have to produce or whatever. Okay, so let's just find the gradient. Now, when you put on that 9, you put it into each of these x values, okay? So you go 3 times 9 squared minus 20 times by 9 plus 24. And then you get 81 times by 3, so that's 2243. Then this is minus 180. Plus 24, and my quick maths is finished by now. Okay, so I'm just going to plug this all into the calculator and figure it out. So minus 20 times by 9 plus 24. And by the way, you know that brick of a calculator that's come out recently? I'm going to get one soon, but I don't know how to use it yet, okay? So I'm going to be using my trustworthy TI-89, which I got for Christmas one year. Yes. Christmas present. Okay, so here we go. We've got 87. That seems massive, and that's the answer. Okay, so that's the gradient. dy over dx is that answer. Then you can actually check it on your calculator. You can sketch out the graph, and at a given value, so x equals to 9, you can sub it in. Hopefully you get this answer. So I hope that actually cleared up a little bit of an issue for you, maybe with differentiation and exactly why you do it. I'm going to be placing heaps more tutorials online, so just keep posted and hopefully it will help you understand the concepts before you enter your exam. Okay, have a great day guys, and I look forward to hearing from you. See ya.